So, very good afternoon. Am I audible, sir? Oh, Ghana one.
Yes, sir. You are audible.
Yes, sir.
Audible, no, sir.
Yeah.
Okay.
Sir, can you see the screen share?
Yes, yes, sir. It is.
Okay.
Hello, sir. Ujjwal, sir. Hello, Ujjwal, sir. Sit down.
So everything is fine, sir.
Okay. Can you hear, sir?
Yes, sir. So, am I audible, sir?
Yes, yes.
Okay, thank you. So, mute it now.
Hello. Hello.
Hello.
Hi.
Hello.
Hi.
Yes.
This room is free now? This room? For just 10 minutes. For 10 minutes.
Now.
Wow. Hello. Yeah, you're able to hear?
Yes, sir. It is audible.
Good.
No.
So, am I audible, sir?
Yeah.
Yes. So, we are starting the program.
Okay.
Okay. So wonderful afternoon to all and one. And on on behalf of National Institute of Technology, Manipur, Department of Computer Science and Engineering, I'm Dr. Ujjwal Vishwas. I'm extending my warm welcome to all dignitaries, faculty members, participants, research scholars, students, and those who are present here in person and virtually for the inauguration ceremony of the 5 days faculty development programs on artificial intelligence, machine learning based healthcare research tools trends and challenges in intelligent medical system organized in hybrid mode with due respect to our Honorable Director, Sir, uh, Professor Dr. D.V.L.N. Somazulu. Also, we are here with us PM Professor B.B. Rao, sir, and also the respected professor from NIT Manipur, Professor Kumantham Mangalam Singh, Department of Computer Science and Engineering, NIT Manipur. And my heartfelt extension to the uh, honor to the expert and the director, a principal from Jyoti Engineering College, Father Dr. Jones, Kanan Pahuja, academic director, and
Ujjwal, they are unable to hear you, other people. So I got one message, just check it. You stand close to mic and then speak.
No, we are able to hear you, sir. Kindly go ahead.
Okay, so now I am audible, sir.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir, audible.
Yes, so I would extend my gratitude to Father Dr. Jose Kanan Pauza, academic director, and respected principal Dr. P. Sujan Lal from the uh, Jyoti Engineering College for uh, for jointly organizing this FDP. In this direction, our directors have motivated us to do this faculty development program with collaboration with the Jyoti Engineering College. I'm very much thankful towards our honorable director, sir, and thank you for all professors from our department and dean academics to support these development support these faculty development programs to organize in a hybrid mode Dr. Khel Chandra Sangam, academic dean, and also I am very much honored to our HOD Department of Computer Science, Dr. Oibam Gina Channu, madam. So, very good afternoon, and thank you for helping us or shaping this FDP forwarding. So, moving forward, I would like to request our all dignitaries and all in person or online, please stand up and prayer for a silent 2 minutes to establish a deeper connection with the divine. So time start now.
Ujjwal, you have to tell who has to speak.
ആണോ? ആ ഓക്കെ. എന്റെ സമയമാകുമ്പോ പറയില്ലേ?
So stop now. So thank you for participating in silence prayer. Those who are in presence and virtually, I thank all of you and all the dignitaries. Now moving forward towards our program. Now I request our PM Professor B.B. Rao sir, Professor Prahalada sir for the welcome address. Sir, please.
Yeah. Good afternoon to you all. Is it audible?
Yes.
Yes, sir. Yes.
Yes, sir. Yes, sir.
Good afternoon to you all the people who are physically present and as well as the virtually present. So I welcome all the people to this workshop. This FDP on AI and machine learning in healthcare. Basically, it is something very new contributions of computer science in the healthcare and all that. So computer science, we have seen, is evolving. Started from early stage where we are focusing only on the number crunching of doing some computations very fast. But slowly, when you have seen today, it has evolved a lot and it is accommodating all the fields. And as a result, what happens is the utilization of computers by all the areas, in all the researchers in the different areas, it becomes very imminent. Nobody can avoid the usage of computers today in their field. And computer science, if you see the progress recently that, and AI and machine learning is dominantly we are hearing today, and AI, this is the era of AI dominating. And though this AI era is not a new one, it was way back in, it started along with the computer science in 1950s, okay? But the progress went into multiple directions. People wanted to see that whether the computers can really do think like human beings, right? So, or they can act like human beings. So the acting as portion was defined as a rationality, like systems, mechanical, right? But acting like properly, and then thinking like human being, like a human approach. So AI field has evolved the last 50 years, 60 years, the direction, and various researchers worked in different directions across the globe. This AI growth evolution happened simultaneously across the globe. And all the four concepts you might have, those people who might have studied in AI, they know that thinking like a human being, acting like a human being, or and all those four quadrants. Okay. And when we see that, then recent terms, basically we started seeing that just by doing doing things in an intelligent way, it also demanded that intelligence basically defined with the learning also. Learning is also one of the characteristics of the intelligent beings. Then how the computers also can learn, that's how the machine learning field also evolved in the recent terms, like last. No, it was though it was old. They're all, but recently they are now dominantly. We are seeing AI and machine learning predominant in the recent terms. Basically, because Along with this AI and machine learning, the other fields like cloud computing and a lot of data required to be available in the on the fly, and all this is taken only in the recent terms. Like I can say that we started grid computing in the area of in the 2007 to 2010 time frame. The spin of that is what the cloud computing, when we are not able to provide enough number of computers on the grid, that means on the internet, then we started seeing that yeah, we started virtualizing these systems. That's how the cloud computing is a spin of grid computing. And then at the end of this, basically people started using computers heavily on internet as well as, so we are able to get a lot of data onto the internet. And that's how the new field like big science, data science evolved in 2015 time frame. And sensing was also started evolving during that 2015 time frame, wherein IoT field has come up into the computer science. That's how the computer science started evolving. And recently we are also started hearing about the quantum computing, and quantum computing is also evolving very rapidly. And people started looking into that, what are the type of challenges quantum computing can take it up and all that. So quantum computing, if you talk about, there are four four verticals under which quantum computing is developing. One is the hardware side, and the other one is the algorithm side, and the other one is basically on the quantum sensing is one area which is very dominantly coming up, and it is the strength of the quantum computing is the quantum sensing, and which is being extensively used in the medical field today. Okay, so basically, yeah, this workshop basically focus on how the AI and machine learning helps the healthcare field, as well as basically I try to give small brief, not brief, my talk. I will focus on how the quantum computing is also supporting us in the healthcare and all that. Okay, so this is where basically, if recently we see that even the quantum, no, sorry, AI and machine learning architectures, we talked about NVIDIA and all that. So they are also now the architectures field is also very good. Progress is there, and today we are able to deliver lot of what do you say, computing on fly, as well as on which is required for the today's applications. That's how the big science, there is a science which say if we see the computers usage sometime back and today, the difference is that there are a lot of big science applications. The big science applications basically talking about the computers accommodating a lot of computations per second. That is we call it computer power. We measure it in terms of floating point operations. Now today we are talking about million floating point operations, trillion floating point operations per second, and all that. Okay, and at the same time the storage. So, and then at the same time, basically the systems coming with the larger RAMs from the architecture side, basically. And then the people who are using in various fields, if you see that there are a lot of areas which have evolved, like the Large Hadron Collider, where people experimented with the Big Bang theory and all that to want to prove that. And within that split second, the amount of data which was generating, it was a big challenge for computer scientists to store the data, and the storage technologies evolved because of that. Okay, so all these things, the computer science basically progressing very rapidly, and all the people, I think most of the people are faculties from the computer science field, and there are a lot of people are expecting a lot of capabilities to be developed from the computer science faculty. So in this direction, we are focusing on the healthcare side, and then in this process, basically, we are also present some of the progresses in the AI, machine learning, and what are the other architectures like quantum computing in this workshop. Okay, I with that, so it's very interesting. Basically, I welcome all of you for this session, for this 4 or 5 days FDP session. Thank you.
So, thank you very much, respected Professor, PM Professor Dr. B.B. Rao sir, and Professor B.B. Rao sir have a vast experience in the field. I feel that we are very much honored for him in the institute itself in NIT Manipur. And this professor, this is under the Anusandhan National Research Foundation, ANRF, Prime Minister Professor. So we get him here at NIT Manipur to build boosting the research ecosystem into our state like this less empowered state like Manipur. So we are very much thankful for him and utilizing his vast experience in industry, academia. So in for the next sessions, I would like to invite our our esteemed professor, Professor Komantham Mangalam Singh, sir, for his valuable overview about our institute NIT Manipur, so that it should be exposed to all the participants, and also as Professor Mangalam as with us physically. So I request one of our Madam Sushma to felicitate him with us all. So next, I will request Sir Professor Mangalam sir to contribute or discuss something about our institute NIT Manipur towards the extent of technology and the ecosystem of research and environment in the direction. So please, sir, few words from your side, sir.
Good afternoon, everyone. All people in physical mode and virtual mode. First, I would like to give my respect to our director, Professor D.V. Allen Somazulu, Professor Prahlad Rao, PM Professor, Department of Computer Science and Engineering, NIT Manipur, our coordinator, Dr. Ujjwal Vishwa, and Dr. George from Jyoti Engineering College, and Dr. Sandeep from Jyoti Engineering College, and participants here, present here physically and virtually. Actually, there were only 20 NITs in the country before 2010. And in 2010, Government of India established 10 new NIT. NIT Manipur is one of them. Again, in 2011, NIT Andhra Pradesh was established. Our first sessions of NIT Manipur start on August 2, 2010. There were only 6 faculty members. Out of that, only 4 are still here. 2 have already left. They have joined some other institute. But currently, of course, now we have 62 regular faculty, and we have around some 50 to 58 non-teaching staff. And our regular session in 2010 August actually start at Government Polytechnic campus. 4 rooms were given to us by Government of Manipur to start NIT Manipur. Their time the number of hostels were only 2, one boys hostel and one girl hostel. Both are again at Tiger campus, Government Polytechnic campus. And at the beginning, there were only 3 branches, means 3 engineering courses: computer science and engineering, electronics and communication engineering, and electrical engineering. Somehow we managed for hostel also at in 2010, of course, there was no girl hostel. We put our girl student in Government Polytechnic girl hostel. Then we start our BTech in civil engineering and BTech in mechanical engineering from 2013. And we start our MTech program in computer science and engineering, civil engineering, electronics and electrical engineering. That time it was called electrical and electronics. Now we have renamed as electrical engineering, electronics and communication, mechanical engineering. We start this MTech program in 2014. Again, MSc in physics, chemistry, and mathematics we start in 2015. And we shift our campus, not total, in total. Some part of this campus is shifted from Government Polytechnic campus to our Langol campus. Now almost all of the departments are in Langol campus except computer science and engineering. We start shifting to our Langol campus. The total area of Langol campus is 341 acres. At the beginning, at 2010, we had a mentor director. His name is Professor P.K. Bose. He was director of NIT Agartala. He was with us for 3 years till 2013 April. Then we had our own regular director from 2013 April. His name is Professor S. Virendra Singh. He was with us for 5 years. And again, the second regular director was Dr. Gautam Sridhar. He was with us again from 2018 to 2023. Of course, he normally sit at Langol campus. Then we did not have a regular director for more than 1 year. From 2024, we had our distinct President Director, Dr. Somya Zulu, Professor Somya Zulu. He has been here with us for almost 2 years. If you see all these things, we start from the very beginning. And our PhD program starts from 2013 February. And number of this thing scholar that time was also less, and number of people who are eligible to guide PhD scholar in engineering discipline also were less. From many of our faculty members and our PhD scholar MTech, we had almost more than 400 essay publications till now. And total number of our patent is published or granted or submitted altogether is around 25 now. And project, of course, many of our faculty have projects, And per year, normally, around 20 projects are running. In the library, if you see, there are more than 25,000 book volumes, hard copy are. Besides, soft copies are available, but normally students prefer hard copy. Besides, we have some online e-journals are available. So students from time to time refer. These are some of the overview of NIT Manipur. Thank you very much.
So, thank you very much, Professor Koimantham Mangalam Singh sir, a respected professor, and his long-standing dedication to the research, teaching, and innovation and institutional development has inspired students, us, including researcher at NIT Manipur. So I'm very much thankful for him to helping to shape this FDP and mostly helping us to encourage doing new things. So thank you so much, sir. Now moving forward, I'm very much honored and privileged to welcome welcoming Dr. Father Jos Kannan Kannan Mamhoja, Academic Director of Jyoti Engineering College, for his overview of the Jyoti Engineering College, as we are conducting this faculty development on a joint mode and jointly. So I'm requesting this Father Dr. Jose to please continue with your valuable overview about the Institute Jyoti Engineering College.
So good afternoon, all of you. The Honorable Director, Professor DVLN Somaya Jalu, who is going to inaugurate the entire FTP and also going to deliver the keynote address. Dr. P. Sojanlal, the Principal of Jyoti Engineering College in Thrissur in Kerala. Various professors from NIT Manipur, Professor Kumandam Mangalam Singh, Khel Chandra Tongkum, Yampam Jena Chanu, and many others, professors of Jyoti Engineering College, participants from various colleges across India. A good afternoon to all of you once again. This is a very exciting chance for Jyoti Engineering College to club together with NIT Manipur. NIT Manipur is on the northeastern part of India, whereas Jyoti is on the southwestern part of India. Miles across, kilometers across, thousands of kilometers. And it is a very exciting situation that we are putting together and making a wonderful FTP on AI and ML based healthcare research, tools, strengths, and challenges in the intelligent medical system for 5 days, starting today and ending by 26th of May. Already the NIT has been introduced. Now from my end, I will be speaking about the Jyoti Engineering College. This is situated in Kerala, the southwest part of India. And we are almost in the center of the whole of Kerala, in Thrissur district. And we started this college in 2002. Now almost 25 years it is going to complete. Presently, we have got 8 UG branches: mechanical, civil, electrical, electronics, computer science. Then we have got mechatronics, also artificial intelligence and data science, and also computer science, cyber security. Altogether, 600 students intake for UG program. Apart from that, we have got 4 specializations in the masters and PhD in all the various branches. So presently we have got around 2,200 students, accounting all the batches and all the branches. And good many PhD holders also we have. Now among the UG programs, 6 are already accredited by NPA. The 7th one is, that is artificial intelligence and data science, is going for the accreditation by NBA. And the visit is scheduled for the first week of July, in 1 month or 1.5 months time. That also will get accredited. Then in that case, out of the 8 branches, 7 UG programs are accredited by NBA. And the last one, which is cyber security, we have to go 2-3 years more, because the final year, the first batch is only in the 3rd year of their studies. So this is a situation, and this is also accredited by NAC with A grade. This is from 2016 onwards. The NBA accreditation is also true right from the year 2016 without any break, and continuously it is getting accredited. So we are one of the leading colleges in the whole of Kerala, and presently this has been conferred with autonomous status. So we are conducting our examinations for the initial years. The final years are still, the exams are conducted by university directly, because it is a university affiliation system. So gradually we are coming out of it and becoming autonomous. So this is a real status. And in many of the areas, we are doing real research. And funded research also we have got in many areas. And this is one of the nice areas where we are putting a lot of focus, lot of energy, so that things can be done. And the present subject also, this is artificial intelligence and machine learning based healthcare research. Of course, years back, maybe a few decades back, we could never imagine things to happen. But thereafter, the computer science took up an exponential growth rate, and things happened in a fascinating way we could never imagine, we could never dream about years back. Now things are happening, especially in the healthcare. And healthcare, as far as Kerala is concerned, we are always #1 in the whole of Kerala, whole of India, with very good delivery for the healthcare services. So we are thinking of getting it amalgamated with this AI tools and facilities, so that we can deliver the best to our people. And this should be extended. It should not be confined to the boundaries of Kerala alone, but it must be delivered all across India, and if possible even outside. And this is our objective, and we are focused on that. And this is in short what we are doing right now. In many areas, we are making researches. We are looking for funded projects as well. Some companies and industries are supporting us with their CSR funds as well. So this is what we are doing. Now, the new branch, which is the artificial intelligence and data science, new I call, because it is only 5 years it has been established. It was established in the year 2020. Now this is the 6th year. This year we are going for the accreditation by NBA. So things will happen favorably, we believe, and we can deliver. And it is extremely happy that NIT Manipur is coming forward to combine with us and to put across this FDP, the Faculty Development Program, to all the people pan-India. And this is a beautiful. Let it happen. I wish you all the best. And just present the details of the Jyoti Engineering College, which is far away from Manipur. but in Kerala. Thank you very much. Wish you all the best. And also the participants, I request all the participants to make use of this golden opportunity and to get the maximum out of what is delivered by various professors, both from NIT, Manipur, as well as from our end, Jyoti Engineering College. Thank you. Wish you all the best. Very good. Nice. Thank you.
So, thank you, Father Dr. Dr. Jose and Academic Director JEC for your valuable words and inspiring talk about the institute and the across India. You mentioned several words related to this Manipur estate and your own estate, Kerala. I feel that it is my privilege to organize such FDP where we meet such people so that it will helpful for new generation for artificial intelligence. Mostly you focus on the few words which I mostly like, that is this AI healthcare system that are now recognizing all over the world. So thank you very much for your valuable words, sir. Now moving forward towards the program, I would like to warmly welcoming the principal from Jyoti Engineering College, Dr. P. Sujan Lal sir. So please continue with a presidential address towards the gathering, those who are online, virtually, and in person at NIT Manipur. So please, sir, continue with the address.
Good afternoon, sir. Honorable Director, DVLN Somyajulu, sir. All others, faculty members of NIT Manipur, of Jyoti Engineering College, and all other distinguished participants joined across from various parts of India. And also I can notice that from Andhra Pradesh, Bihar, Chhattisgarh, Goa, Gujarat, Jharkhand, Karnataka, Kerala, Maharashtra, Manipur, Odisha, Rajasthan, Tamil Nadu, Telangana, Uttar Pradesh, and West Bengal. So I can see participants from across the India, from various places. So first of all, welcome to all of you for this program. And also I've seen that Reverend Father Dr. Jose Kannambur has given a brief of our institute and the position. And hopefully later on, when you have time, please to visit the God's own country. So this is how we started with interacting initially. And I'm also happy to say that my student of Professor Somyajulu sir in the year 91-92 at NIT Warangal, and that is how we started. And also I got some email from some of the participants. They also mentioned that they are the students, now professors with so many degrees and all, serving in various parts of this country also. So my sincere appreciation to NIT Manipur as well as Jyoti Engineering College for organizing such a very important program for the faculty development. So it is indeed a matter of great privilege and happiness to address this distinguished gathering at the inauguration of this faculty development program on AI and ML-based healthcare. And as you know that healthcare is undergoing a major technological transformation. The first one is AI enabling. The purpose is to early diagnosis and medical image analysis, predictive active healthcare, and also you must be knowing about various wearable and remote monitoring systems, and also the possibilities of personalized medicine. And ML is helping the healthcare becoming faster, data-driven, accessible, and it is affordable. So in summary, we can say AI and machine learning are no longer futuristic concepts, they are becoming integral components of modern healthcare systems. And it is very important that we do on the ethical concerns like the privacy and in certain cases the bias to the algorithms, the reliability as well as the inclusiveness. I'm sure that during the coming days, these will be addressed. And it is very important to note that particularly faculty members as well as for students, the involvement of the interdisciplinary collaborations. Likewise, the engineering, medicine, data science, and the public health also. So as educators and researchers, our responsibility is not merely to develop intelligent systems, but to ensure that the systems serve humanity ethically and inclusively. So focusing on this FDP, the relevance, as you know, that requesting all to update the knowledge frequently, and we do promote the collaborative research and the bridge the academy and industry. I think some of you are already attended our previous FDP on almost on the similar topic, where we had lots of industrial people who were addressed also. And this time we have given more concentration on the academic side and the technical aspects. And also it has to encourage the publications, patents, startups, and funder projects. So maybe I would expect that the participants will get a benefit on coming as an outcome. Maybe after within a year or two, you should have a good publications and patents and startups. And AI healthcare is high impact, interdisciplinary and research domain. So in summary, we say that engineering education today must go beyond classroom and examinations. It should empower faculty and students to solve real societal changes through innovation and research. So let us think about the collaborative approach with the Jyoti Engineering College and the Manipur NIT leadership. And we do come out with hopefully with lots of other collaborative opportunities. So collaboration such as this between these two premier institutions are essential for building a vibrant research ecosystem in emerging technologies. And now let us have, I encourage all the participants to utilize this FDP not merely as a training program, but as a platform for intellectual exchange, research collaboration, and future innovations. Once again, congratulations to all the organizers for timely initiative and make this FDP a grand success. As well as once again, my sincere thanks to my own Professor D.V.L. and Somyajulu sir for accepting our request to jointly host this. Thank you all, and let us hope we'll have a wonderful time ahead. Thank you all.
So thank you so much, Dr. P. Shojanlal, Principal, Jyoti Engineering College. I'm very grateful for him, as from the initial days when we proposed this faculty development program, I was very happy that across a state like from Kerala to Manipur, he also mentioned that how many states, faculty members, research scholars, and the PG students joined in this FDP. So I'm very much proud to organizing these FDP with the help of all respected professors from Jyoti Engineering College as well as from NIT Manipur itself. So thank you so much once again, sir, for your presidential address here in the FDP. Now, I would, I'm very privileged to introduce our own director, Dr. Professor D.V.L.N. Somozulu, sir, an extreme academic leader, researcher, and administrator with over 37 years of distinguished experience in teaching, research, and consultancy and outreach activities in the field of computer science and engineering. Professor Somozulu sir joined the National Institute of Technology, Manipur, as a director on 1st June 2024. His academic journey began at National Institute of Technology, Warangal, now from September 1988, and where he served with a distinction and promoted to Professor of Computer Science and Engineering in the year of 2006. Throughout his career, he has held several key administrative leaderships, including director post, head of the Department of Computer Science, Dean Academic, and many more. Professor Somozulu sir has also played a transformative role in strengthening the technical education and the institutional development. He initiated BTech in artificial intelligence and data science, along with the MTech and PhD program at Indian Institute of Information Technology, Design and Manufacturing, Kurnool, as a director of IIIT DM Kurnool. And also design, he was a director there from 2019 to 2024. He played a pivotal role in establishing modern academic ecosystem, including the state-of-the-art classroom, laboratories there, hostels, seminar facilities, and advanced research infrastructure there. Under his leadership, several innovative facilities such as the Samsung Innovation Campus Lab, Drone Studio, and 5G use case lab are one of the most popular. Now, an researcher and mentor, Professor Somozulu sir, has published more than 55 research papers in reputed journals and conferences, and supervised more than 14 PhD scholars, and also executed research in charge as director of Indian Institute of Information Technology, the Kanchipuram, also in the Indian Institute of Information Technology, Three City, and in different places he was in the director post. So today I'm very much honored and thankful for him for inspiring us to across India FDP organization over at NIT Manipur. Today we are privileged to be guided by such a visionary academician and academic leader. Sir, please join me in extending an one welcome and heartfelt appreciation to Professor D.V.L.N. Somozulu sir for extending his huge words in the direction of inaugural address and keynote address towards this faculty development program. Thank you, sir.
Thank you, Dr. Ujjwal Biswas, for giving a long speech about myself. Right. First of all, I'm happy to see my student working as a principal at one of the prestigious engineering college, Jyoti Engineering College, and then organizing a joint faculty development program along with me. In the sense that as a part of NIT Manipur team, he only initiated this activity maybe 2 months back. He sent a proposal. Then immediately I forwarded the proposal to the department. Department in turn identified their people who can participate and then coordinate. And then finally today we are organizing this program today jointly with Jyoti Engineering College. So faculty development programs basically helps to establish good connections between the faculty across different states and different domains of researchers, and also collaboration with students, and then exchanging of ideas from the students. All these things can happen as part of FDP. My view is faculty development program should not be a one-side go. It should be highly interactive. Whatever is there in the books, there is no need to teach. Only we have to motivate and guide the young researchers and research students and the faculty members who are interested in pursuing their research or strengthening their research in the cutting edge areas which are very important today. So I say healthcare is one of the critical emerging area, and building the solutions which are amicable and practicable for clinicians is important. You all know that AI is everywhere today. AI is not just a computer science baby. AI is a baby for all the domains. So that's why today a lot of applications are there for AI in different fields of engineering, science, and other domains. So keeping that in view, as a student, students should understand not just learning the techniques, but they should understand how to apply the techniques on solving real world problems. So that means to say there are different kinds of data available today with all of us. Olden days, there is a concept which was very popular maybe 15 years back, we call as a business intelligence, where the standalone data repository is used to provide insight and identify the useful patterns for strategic decision making. But today, the concept of BI, 15 years back, when I was a faculty at NIT Warangal, I organized a 3-day real-time practical workshop on business intelligence. Around 75 people appeared in person all over the states. And we are the first people introduced the course of data warehousing and data mining in the combined states of Andhra Pradesh and Telangana in 2005, 2006. So after our introduction of the course and providing good hands-on training on the course and the exposure of practicals, all these things motivated the young faculty to revise their curriculum because of the industry demand. Right? Today, after 15 years, I am seeing the importance of AI today everywhere. So that means to say, all the faculty, whoever is working in Jyoti Engineering College and also whoever is working in NIT Manipur, they should collaborate and then start applying these methodologies, AI methodologies, and machine learning techniques in a wide range of practical healthcare data. Data is everywhere today. So understanding the data, cleaning the data, processing the data, modeling, implementation, deployment, and then improvement, all these things are part of the analytics life cycle. So data analytics are of different kinds. As my student Sojanlal mentioned, there are different kinds of applications are there in AI, in healthcare, early disease prediction, and then understanding the patient's needs, and then the requirements, and then how quickly we need to take a decision. See, decision making is order of the day today. Quick decision is to be made by analyzing real-time data on the fly, by taking all the relevant data which is available in different mediums. Today, different mediums in the sense, I say data is maybe a structured data, some may be semi-structured, some may be quasi-structured, some may be completely structured. So there are different types of data available. And then your video data, audio data, genomic data, healthcare, all sorts of available data needs to be analyzed. That means we need to provide good algorithms, good models, good efficient algorithms, accurate models, then applicability, usability, correctness, all these things are important. So therefore, whatever you do, it is what I feel is 15, 20 years, the last 4 decades, I worked as a faculty member. I introduced several courses. Whatever Sojanlal mentioned, we also introduced a privacy preserving data mining to ensure the privacy and security aspects of the data. And whatever the fundamental courses are there in computer science, particularly all these fundamental courses are viewed in a different way today. That means I always look at the concepts will never change. Only technologies and tools may change, demands may change, but the students, whoever is having a strong fundamentals, they are always go with flying colors. Whatever the technology changes are happening in the industry side. But it doesn't mean that we should not use, we should not learn, but we have to learn some additional things, but fundamentals are very important. So keeping that in view, how quickly you learn the new things and adapt to the emerging roles in industry is important today. That's why most of the institutions are encouraging the students to learn the skill-based courses, skill-based training are important. Now, you know that AI is not only in healthcare. So, for example, in education system, a lot of changes are happening with the role of AI in education. So how to reduce, how quickly you can provide assessment, how to provide responsible learning for the peers, then how to do assessment automation, so that if students should know where they are wrong, where they are right, that should be quickly known, and it should be derived from the data only. It is not based on the intuition of the teacher. It is based on the evidence-based decision making needs to be done. So these are all very important. So I'm very happy that the NIT Manipur Department of Computer Science and Engineering, Ujjwal Biswas and the faculty and head of the Department of Computer Science and Engineering, along with Professor ANRF, Professor Prahlad Rao, they're all actively participating in organizing this program. and planned several sessions, but all the topics, whatever you learn, whatever the speakers are going to deliver, please interact with them. Feel free to ask your doubts without any hesitation. And then even if you don't understand everything in the short day, but understanding and then learning the gaps, and then where we can do and where we can contribute, if you identify, that itself is a great learning for everybody. So with these brief remarks, I once again welcome all the participants who joined all over the states for this FDP, jointly organized by Department of Computer Science and Engineering, NIT Manipur, and Jyoti Engineering College, Kerala, for coming up this wonderful idea. So, as Professor Sojanlal mentioned, FDP is only just a beginning. We need to do a lot of collaboration, lot of joint proposals, and then joint research guidance, joint paper publications, all these things, but with accountability. Just putting the name is not give a joint. Accountability, work responsibility, and then proving of the work done by each person, each team, is everything is important. So with these things, I request the coordinators to also conduct the assessment test at the end of the workshop using AI tools. When you are learning AI and importance of AI in healthcare systems, assessment also must be done through AI tools. So please use one session workshop, and then prepare all the questions from AI tool on some domains, on topics covered, and then ask the participants to solve. They can use they can use AI tool and solve, but the questions should be prepared in such a way that they should think and solve the questions. So this way, learning will happen. See, learning always comes with the responsibility and accountability, then evidence. So all these three are important. So I request all the organizers, please take care of this, and then just online programs, maintaining the attention, and then interaction is very important. Otherwise, the speaker is only going to speak to the walls, which is not going to be useful, unnecessary waste of our time. So please utilize this time very effectively, and then learn in a best possible manner. Whatever the best you can do, you exhibit it, and then submit a one-page summary report about your learning outcomes of this program, and also provide suggestions for improvement. If any gaps are there, that also you need to give, so that next FDP, whatever changes are required, we'll make the changes based on your feedback. So these two are very important. So with these brief remarks, I once again thank Professor Sojanlal and his administrative officials from Jyoti Engineering College, and also the head of the Department of Computer Science and Engineering and other faculty of Computer Science and Engineering for planning and then starting this program today for a period of 5 days. Thank you. Wish you all the best. Thank you.
Thank you, sir, for the wonderful introduction. And as you mentioned, sir, at the end, we'll have one-page summary, and also we'll take that's, I think we'll note down that, and maybe that may be a submission of that along with the last day.
Maybe when you are a student, we have not learned all these things, right? Because we always used to spend our times only in the laboratory 24/7. But today's situation is different. So that's why I want to find some way out to enhance the quality of learning in a best possible manner, because technology is changing, people mindset is changing, and timings are tightening. So keeping all these things, we have to find the way out. So
and also your point said about the use of AI tools is also extremely important, because I also learned from industry people that the use of AI tool is very important, and people who are effectively using getting a lot of benefit, not only financially, but also time-wise, and they're
Correct.
effectively utilizing. So that's,
Labor work can be reduced.
yes, sir. Correct.
So actually, I want to highlight one more point. I was there in the committee constituted by Minister of Education on impact of AI in other domains of engineering, how to revise the curriculum, how to encourage the non-computer science students to get into better jobs. For all those things, I shared all my views, and the committee chairman is the director IIC Bangalore. We all submitted the report, and two things we have introduced. We need to put a design thinking with AI course. Already I introduced in NIT Manipur this semester. Design thinking with AI, and mathematics courses need to be revamped in a big way in order to give more strong background of mathematics to AI. Without mathematics, AI cannot be learned by anybody. Physical interpretations, understanding, computation, all these things are important. So these two are very critically suggested. I will share that curriculum, that report to you. You can see it. If good things, you can adopt it.
Yeah, and also just as you mentioned about the mathematics part, the design thing you also mentioned, the application of mathematics in engineering, one of the proposal which you are going to make. So in that, maybe I will include NIT Manipur also, sir.
Yes, sure.
So that will be discussing offline, sir. And also you said about the design thinking. That is also another extremely important subject, and that is also we'll discuss outside. So we'll see how we can collaborate, as well as the attendees, faculties who are attending. Please think of these 2 points in addition to that: application of mathematics in engineering. The other is design thinking. So really great, sir. Thank you. Over to Ujjwal, sir.
Thank you.
Thank you, respected Director, Honorable Director, Sir, Dr. D.V. Ellen Samajulu, Sir, for his kind and valuable words to inspiring us and motivating us to do some faculty development program and working on using several AI tools and other revision of syllabus. In his talk, he also mentions that revision of syllabus is a very important in academia, because it is always required. It is observed from his visionary CV that we have seen that artificial intelligence and data science also introduced in the year 2019 and 20 between this. So I am very much proud and thankful for him to guiding us in this direction. So thank you so much, sir. Now,
thank you.
So now I will welcome and request our academic dean, Dr. Khel Chandra Sangbang, sir, for his valuable introduction about the FDP directions and valuable information regarding the topic AIML and based healthcare research future perspective to the direction of this faculty development program. So I'm still thankful for him for managing time for us to provide such topic, selecting such topic to discuss here in the faculty development program. Sir, Dr. Khel Chandra Sangbang, Academic Dean and Associate Professor in the Department Computer Science and Engineering. So over to Khel Chandra, sir, please.
Thank you, Dr. Ujjwal, for inviting me in this inaugural program. So, respected Professor Swamajulu, Director, NIT Manipur, then Professor Manglen, Professor Parlada, then Dr. Jost, Academic Director of Jyoti Engineering College, then Dr. Swajanlal, Principal, Jyoti Engineering College, then Dr. Ujjwal, then Dr. Yamyunjina. So all faculty members of CSE department, all staff, and my dear students, a very good afternoon. So I would like to say that this FDP is very important because we all know that this artificial intelligence and machine learning, they have become an integral part of these modern healthcare systems. So right from disease prediction, then disease classification, then robotic surgery, then remote health monitoring, whatever. So they all use these AI-driven technologies, and this technology is like rapidly setting the future of this healthcare research. So in recent years, so what this healthcare sector they have done is they have gathered a huge, enormous amount of data from like biomedical databases, then from sensors, from like medical imaging signals, from everywhere. They have gathered huge amount of data, and using this data with AI ML, like this using this these AI models, they have contributed significantly in areas like this cancer detection, then cardiovascular prediction, disease prediction, then drug discovery, then like health monitoring, remote health monitoring, and all these. So apart from this, like two very important areas I would like to mention. The first one is like the brain computer interfaces, popularly known as the BCI. So BCI, what actually is BCI? It is a technology that establishes a direct communication pathway between the brain's electrical activity and the external device like the computer, the robotic limb, or the wheelchair. So it establishes a pathway. So by interpreting this neural signal, so it allows the users to control the hardware or software from their thoughts, from their thinking. So this BCCI, it works in 3 steps. The first one is the signal acquisition. So like using electrodes or EEG, the signals will be acquired. Then after the signal processing will be done using AI ML to decode these electrical patterns. Then the third is the execution. Once we have these patterns, so executions to translate this into commands or executing actions for what actually the person want to do. So this BCI, this application, this is used, and it will be very helpful for persons with for paralyzed persons and persons who have stroke, who actually want to communicate but cannot communicate. So I hope you already know this BCI. So we can work on this BCI. And the second area is the computer assisted surgery, popularly known as the CAST. So actually it is a modern surgical approach which uses computers, then advanced imaging, then navigation systems and robotics and AI. And actually, it helps the surgeon to perform operation with greater accuracy and with safety and precision. So in CAS, what actually the surgeon, they will remain in control of the operation, while the computer systems will provide real-time guidance and support the surgeons or the doctors during the surgical operations. So the computer system will actually display the exact location, the exact positions of these equipments or instruments that are used in the operations. So this is the second area that I want to tell you, the cost. So actually the future of this healthcare using AI, is not to replace the doctors actually. It's about guiding them to increase precision and minimize the damage actually. So with these few words, I encouraged all the participants to actively interact with all the experts and utilize this program as a foundation for their future research. So thank you all.
So thank you so much, Academic Dean Dr. Khel Chandra Thangam sir, and he is contributing this institute since 2011. So he is always inspiring us to do good things as NIT. So I'm very, very happy to thank him for his valuable words in the direction of AI/ML based healthcare research and future perspectives. So in several meetings, he also mentioned that why this AI/ML is important nowadays. So almost all speakers agreed that these AI/ML is very, very important in the healthcare sector and healthcare research. So I'm very much thankful for Academic Dean from NIT Manipur, and he belongs to a computer science department. So I'm very much happy for his valuable words. So in moving to the next program, continuing. So this is the last part of this first session. So our HOD, Madam Dr. Oibam Zina Channu, Associate Professor, Head of the Department, Computer Science and Engineering, NIT Manipur. So she is online. So I will request her to make a vote of thanks for the program of the inaugural ceremony of the first session. So can you please, ma'am, join and provide and inspire us with the word of thanks to the gatherings or all the participants, researchers who joined virtually also. So over to Madam, please, ma'am.
Okay, good afternoon. Am I audible?
Okay. Yes, madam.
So good afternoon, everyone. Myself, Dr. Yambem Jinachanu, HOD CSE. I have given the privilege to provide the vote of thanks by our coordinator, Dr. Ujjwal Biswas, and he's very energetic. So let me start my vote of thanks. First of all, I would like to thank our Honorable Director, sir, who provided us our good energy. And then he also stated few tips for the participants of this particular workshop. And we also feel that we'll execute whatever our sir mentioned. And then sir specifically mentioned about AI uses in certain area. I mean, sir also told that for non-engineering, how we should able to uh, make them to learn AI. That is the focus, sir mentioned that one. So thank you for your valuable suggestion. And next, I would like to thanks Dr. P. Sodalal, Principal JEC, for his encouraging words regarding collaborative things and all. So from as an HOD of CSE department, I'm looking forward for more collaboration in future. Thank you, sir. And next.
Oh. Okay. Three, no?
No, presentation means
Which stream? Mechanical. Yeah, okay. Fine. Mine is three.
Oh, okay. You will be joining also.
Yeah.
Continue. So, HOD madam, are you there, madam?
Her audio might be affected. Audio is not.
Yes. Am I audible, sir, now?
Yes.
Yeah, you're audible. You're audible. Yeah.
Okay. So, madam, HOD madam, are you there? Madam, please continue the board of thanks to the gatherings, please.
She got disconnected. You can continue and close it. No problem.
Okay, sir. So, thank you very much for participating in this first session. I believe that from on behalf of my HOD Department Computer Science and IT Manipur, I'm very much thankful for her and all the professors, directors, and the most important participants. Very good afternoon, and thank you to all. And we'll start the session again as scheduled. So thank you for these sessions to all of you, and I feel that in future we'll get more learning or interacting with you all participants. So thank you very much for participating in this session.
Thank you all.
And
Thank
let's
you.
be successful.
Yeah, thank you.
Thank you, Prajwal.
Hello, hello.
So once again,
Sir, there is no audio actually.
so am I audible now, sir?
Yes, sir, audible.
Okay, so very good afternoon to all once again. So one of the expert today is not available due to his interview. He the as NIT Manipur, there is a recruitment process. So there is a problem for this continuing this session, but still I feel that I will myself continue the discussion of my own topic, which was previously scheduled on 26. So instead of that, probably this Anil Brucer will continue up tomorrow or day after tomorrow. Will reschedule that based on his availability. So now, for the time being, I am continuing for the session for on the topic which I have already shared. My topic was the presentation or FDP topic was to extend this QML and also uh, also the topic on machine learning and generative AI in the field of medical intelligence system. So uh, today I will continue half an hour for the brief demonstration about the topic which I'm planning to cover today, because I was not well prepared also for this session, but unfortunately, we are continuing this topic instead of this schedule. So out of this schedule, I'm continuing this topic. So I am very sorry due to the inconvenience, but it is true fact that he joined in the professor interview, so I cannot force him. So I'm continuing with the topic which I said. This was on the day 26, quantum ML and Gen AI in preliminary disease diagnosis. So mostly I'm planned for today's session for covering the very basic about the introduction of the quantum machine learning, and based on that, maybe I will take another half an hour session after this on Anil Viruser. I will request him to provide me half an hour session, and in the next session, which will reorganized again. So, so I'm continuing about the introduction to quantum machine learning. So nowadays it is very important topic. If we check that quantum machine learning is a broader area of work, mostly due to the importance of computing and uh, improvement in execution time. And most of the people, those who are doing research on the direction of quantum machine learning. So quantum machine learning is a combination of quantum computing and machine learning. So it consists of these two words. One is that this quantum, and another one is the machine learning. So these three words are very, very important to know nowadays, because in the most of the cases, in any research areas, in any advanced research cases, we observe that quantum machine learning and quantum computing are frequently used due to the execution time and helping execution time reduction. So it is a combination of quantum computing and machine learning, and now also it is becoming a new topic or new era of computing. And it use principles of quantum mechanics for intelligent systems. So it internally use the quantum mechanics for the intelligent system. Intelligent system here, I mean that mostly when we are covering the intelligent system, that means it should work uh, in advanced directions. So use principle of quantum mechanics. So with the help of this quantum mechanics, if we generate, we create or design some devices which should be as intelligent as human. So that is our objective, to use the combination of quantum computing and machine learning. So the major aim and objective of the use of the quantum computing is faster computations. That means in the computer science sense, that it should be execution time should be less, and a better learning performances. So this is the emerging field in AI and quantum computing. So application in optimization. So it mostly works on application in optimization. Majorly, we are discussing on the major important topics, which is the healthcare and agriculture, and as well as the cyber security. These are the more generic terms which is used in this direction or in this area of research. So people are working nowadays. It starts from 2010, and people trying to use that quantum mechanics into the computing. So mostly after 2010, we people, the researchers and other people, those are working hard on the topic. So now recently it is going populated throughout the world, and everyone people were talking about this topic, which is quantum mechanics, and mostly this quantum computing and machine learning for the computer science students. Now, the basic principles of the QML. If we concentrate on the basic overview about the topic, it is very important that the first one point is the qubits instead of the classical bits. So this is the point to discuss that uh, uh, qubits instead of these classical bits, and also it uses superposition, enables multiple states simultaneously. So simultaneously it uses superposition, enables multiple states, uh, and also entanglement allows the correlation between the qubits. So yeah, correlation is also important in entanglement allows the correlation between the qubits. So I said that qubit is a classical, instead of this classical bits which I studied in digital electronics. Instead of that, this concept of the qubits is very important to represent the state and executing the problem and implementing it into real intelligent application. And also the superposition levels multiple states simultaneously. Entanglement is another very famous word now, so allows the correlation between the qubits. And also this quantum interface improves the computation efficiency. So that I have discussed initially from the beginning, that this quantum interface improves the computational efficiency. And here, this is very important to discuss that computational efficiency means in computer science the execution time. So quantum interface improves the computation efficiency means it is helping us to reduce the computational time. That means the time complexity. So this directly helpful for quantum interference for improve the computational efficiency. Now this quantum circuit process information using the quantum gates. So here, if you check this slide, it is very vital that it should be of it should be continued with the qubits instead of these classical bits. And also so a few quantum interference and also this execution time and this quantum circuit and qubit. So from this slide itself, if we summarize that this in QML mostly we have to think about the bits instead of the classical bits. We call these qubits, and also the concept why which is superposition to enables the multiple states. And next topic, which is entanglement, which actually helps to correlate between these qubits. And also this quantum circuit is important to deploy or coding in quantum machine learning. So So regarding the history of evolution and algorithm of this QML, we observe that it started in 1980s, the foundation of the quantum computing. But in 1994, some algorithms also introduced. In 1996, 2000s, the growth of quantum information science, and 2010 onwards, integration of ML. So I have already pointed out this topic, that which is mostly the integration of QML with a quantum computing. So in 2010 onwards, it becomes the concentration of the computer science people, that how will introduce, how will use this machine learning into a computing, which is popularly known as this quantum computing. So in modern era, there are QML algorithms. So these are the more important algorithms which are more popular nowadays to implement it in a real decks or into it. But still, it is very clear from the research work and other activities by the researcher that it is very challenging to use this quantum qubits and executing it in a real way. Or still the world is going to changing the way of computations with the help of this quantum machine learning. But there are many challenges to implement these algorithms into a real way. Now, so these classical bits only these binary. So have you now am I audible? Am I audible? Yes. Can you please cross check? Am I
Yes, sir.
audible?
Yes,
Yes.
sir. You're audible.
Okay. Thank you. Sorry for this interruption. So we are talking about the history, evolution, and the algorithms of QML. And one important questions which is always comes that how these quantum bits and these qubits and also these classical bits are different. So I will detail out these on the next presentation when I should discuss elaborately on the basic topic on that. So mostly today I'm going to discuss about the brief idea about the qubit and other QML techniques for the popular for the QML and other things. So these are the history, evolution, and algorithms of the QML, which is QSVM, VQC, and quantum neural network QNN. So K means so only difference is always when we are performing this algorithm, always it is required to make the bit changing into architectural changes into qubits. So whenever we are really implementing this, that is important to sense it into according to the computational point of view or quantum mechanics. So that's the reason for classical bit and qubit is important to know. If we know both of these, then it is very important to implement and how we'll convert these classical bits and information into a qubits. That is important when we will really make a simulated bed or actually executing that into a real base. Okay, so I feel that more details I will provide in the next session. So intersection of QML and machine learning. I said that this QML and this machine learning both are combined words. This was my first topic and first definition of the word QML. I have said that QML combines both the technologies. We know that obviously we know that machine learning and QML, this quantum mechanics, both when we combine, then we get the classical ML handles the large data set. Quantum computing improves the computational speed. This is very, very important, topic, that quantum computing improves the computational speed. So mostly we are focusing on, as in you see this processing unit and processing time is very important, as we are real time processing. Real time, we are going through a real time processing, real time system improvement. So if it is required real-time execution of the program, it is always required to speed up the computational time. That means it should be reduced the speed time. So time complexity should be reduced. So in this direction, a lot of researchers are agreed that this quantum computing improves the computational speed. So next, this quantum QML combines both technologies we have already discussed, enhance the feature extraction and optimization. I have said that feature extraction is a major phenomena in machine learning, where extracting feature is a very, very important or key component. So enhancing the feature extraction is very important, and also optimizing them to reduce this computational speed. So computational speed should be reduced based on the feature extraction and optimization. If there is a possibility to optimize the feature, and also extracting the less features means less feature means the execution time, access time should be reduced, and based on that, maybe speed should be increased. So again, another important topic, which is reduced training complexity. You see, these are the complexity based on the machine learning. These are both are true. Like the feature extraction, optimization is there in machine learning also. Now that is also in quantum machine learning. That is also there. Reduces the training complexity is the vital point when you are training a real-time system based on any application, any intelligent application. So for any intelligent application, these two parameters are most powerful parameters that we can think about: the feature extraction or a feature optimization in the direction of reducing the training complexity and also execution time, reducing the execution time. So useful in deep learning and pattern recognition also. So you see this QML is not as a single words. Now, if we talk about the QML, that means we are collaborating on combining several fields like mathematics, computing, quantum mechanics, now this machine learning, now this feature extraction, optimization, and reducing the training complexity. Whatever it is, both it is also related with the deep learning now. So you see, it's not the single area of research. It's a combination of all all kinds of techniques, tools, everything knowledge is required when you are implementing a QML. So for implementing a QML-based or actual machine, it is also very vital. I feel that it is required lots of knowledge to understand the concept. In QML, when you are designing an intelligent system, and so next, why quantum machine learning? So I have already discussed that our major objective was to faster the processing of the large scale data. So always large scale data should be reduced into a fewer data. That means that is called the extracting the features, which ones should be the most important features for implementing the intelligent system. And next one is also how it improves the optimization capabilities. So optimization capabilities to produce that intelligent system into a improved optimization capabilities for the intelligent system. And it is also that ability to solve that complex mathematical problem. So quantum machine learning, I said itself that the ability, it have this ability to merge with deep learning, machine learning, and also quantum mechanics. So ability to solve these complex mathematical problems also, and also it works. It is parallel computation through a superposition. I have introduced this word also previously, that superposition with the help of computational through the superposition concept, parallel computation also possible. Now this potential exponential speed up over a classical ML. So we observe that whenever we implement it, it is also potentially exponential speed up possible over the classical machine learning. And that's the reason that people are moving from this machine learning into a quantum machine learning. So it helps to better performance in high dimensional problems. So in high dimensional, in the sense that high dimensional data, and reducing that data, that is, I said that feature instructions. So it works better for performance in high dimensional problems. So high dimensional problem means the complexity. Here we are talking about the complexity of the problems. So if the complexity of the problems increases, it is obvious that the better performance in high dimensional problems, it is always required. So in this direction, these quantum machine learning works better. So that's the reason that people like these quantum machine learning now. Now, if you think about these quantum algorithms for machine learning, so quantum support vector machine QSVM that we have already introduced, and quantum neural networks, it merged with the quantum and neural networks concept into, it combines itself again, it combines the concept of the neural network into a quantum computing. And the variational quantum engine solver, DQE, and quantum approximate optimization algorithm. These are the optimization technique which is used when you are really trying to implement into a real bit. Okay, so quantum principal component analysis, QPCA, principal component analysis, also very popular. Only this PCA also very popular in machine learning. So this principal component analysis is important in machine learning as well as when you are implementing it. I said that in previous slides that better performance in high dimensional problems. So when dimensional of the data is to reduce, we have this last point, this slide. So based on that, it is this quantum principles, component analysis, QPCA, are very important, and also some Grover's search algorithms and HSL algorithm for solving linear equations. So these are the popular technique algorithms for machine learning, which is quantum machine learning. Now it is advancing. Okay, so is there any questions till those who are online or virtually available here now? Is there any question to me up to this point? Hello, participant, is there any question up to this? Those who virtually present, is there any question up to that part? So if you don't have these any questions, then I will continue. It is working. Huh? Am I audible? Let's check in YouTube. So is there any question to me? So it is working. Okay. So if there is no question to me, I will continue with next slide. So how to perform this QML? So how to perform and how to quantum data representation technique. In quantum data representation technique use, these are the basic encoding, amplitude encoding, angle encoding. Angle encoding is very, very important in QML or quantum machine learning. And also, I have said that the qubit encoding, tensor product representation, quantum Fisher map, efficient representation of high dimensional data. These, if you check these topic, all these are very, very important for quantum data representation. So data representation is another major concept. Always it is true that how we will represent the data. If we change the data format, what should be the problem when we are executing or implementing it. So based on quantum data representation, technically it is required some encoding technique, and also representing that data in the new form when you are implementing in the real bed. So whenever you are implementing in the real bed, it is always true that what type of data you are encoding, what type of data you are processing. So based on that, in quantum machine learning or quantum data representation helps to represent that data into the quantum bits, or and it is basically features for the intelligence system to train it. So basic representation, these are the quantum data representation technique. So now, how to perform this QML? Okay, so it is important to check that collect and pre-process the data. It is not only true for the QML. It is true for all real life applications. It is not particularly required for QML. It is also true for the machine learning. problem in machine learning concept, it is also very popular thing that these collect and process the data. Now, based on this processing data, I said that previous slides that encoding is important. It is required to convert that classical data into a quantum state. This is very important. Quantum states and classical data into quantum states. So next state is it is required to encode classical data into a quantum state. Now this next step is build the quantum circuit. So building a quantum circuit, it is also required to know the quantum state and these collect and pre-process the data. Based on that, you can build the quantum circuit. And applying these quantum gates and algorithms, it is important which algorithm is suitable for your representation for your quantum circuits. So applying these quantum gates and algorithms also is a vital part, and also train hybrid quantum classical models. This is also quantum classical model through hybrid conversion that train how to train them, so that you have to know internally what should be done, so that the classical data can be converted into a quantum state, and it should be trained also. Now it is also true that how this performance should be measured during the quantum outputs. Measuring these quantum outputs also very challenging now still. So researchers are focusing on how to measure these quantum outputs, so that how you will compare. Nowadays people are comparing this classical method, classical performance with the actual quantum computing process, and also evaluate the model performance. This is very common. This is not for true for the QML only. It is true for any machine learning problem, any integrated machine learning problem, any advanced problem. The evaluation of model performance is very important. Now, if you think about the quantum mathematics behind QML, I have said that previously that it is very important to know that not consisting only the simple concept, only not this machine learning, only not this computing. It talks about several things. So understanding that direction and that dimension is very important for the computer science students, computer science researchers. As a computer science researcher, it is always required to know the background or the mathematics behind the QML. So mathematics behind the QML, it is obvious that you have understood linear algebra is another most vital in mathematics, so that can be reused or reutilized in vectors and matrix, eigenvalues. These eigenvectors, these are most popular tools in advanced machine learning system, as well as in QML, that means quantum machine learning. So complex numbers, tensor products, quantum state representation using direct notation, and quantum state representation. So normalization. So these are the most popular mathematics which we should have to discuss on more details, so that we understood the topic more on less. So mathematics behind QML. So we are talking about this mathematics, that basic mathematics. Everyone knows. I feel that as an engineering graduate, so everyone at least gone through these mathematics at least once in the curriculum. So I feel that these are the most mathematical part which you have to go through once again for implementing the QML model into real bed or real quantum machines. So next, if I think about the practical application of QML, like this, nowadays I said that already this drug discovery, plant disease detection, financial prediction. So these are not only these QML problems, it is true for machine learning problems as well. Now we are going towards these computing, quantum computing, due to the objective of reducing the execution speed and as well as making a problem simple to execute, and training speed should be reduced. So based on that, these are not the popular problem for only practical application of the QML. These are all true for any machine learning or any intelligent problem discussion. So this is not true that always this is practical application of QML. So this is always, people may contradict that this is not these QML problems. So that is true, that based on the PPT, it is good to see that these are the problems. Maybe in these problems, people are mostly working. So I have mentioned these few which people are mostly and now are concentrating to discuss. So so next, the tools and resource for the practitioners. These are very important. This is our topic, which itself we discussed that in the if you check the faculty development program title itself, it talks about tools and the trends, challenges of the machine learning AI in healthcare research. So itself, whenever you are implementing into a QML into a real simulated bed or any implementation, in that case, these IBM tools is very important. Google tools also there, and also these are the popular tools which are TensorFlow, Quantum, Amazon. These tools also popular. Microsoft also developed some toolkits, and these are the Jupyter notebook also. This is not for only this quantum machine learning. We will also using the Jupyter notebooks to real weight, and Google Cloud something we also use, but mostly we face several problem of crashing the system when you are implementing, when you are increasing the ECOPS to execute the problems. So really, in real fact, during my implementation also, I faced several challenges. I have already published 3 conference paper on the recent trends of QML. So I know the practical challenges are there not only in India. It is true for all over the world. People are doing research how to make it very simple and how to make a quantum computers for developing such a concept in QML. So these are the useful platforms which you can take, which will help you lot when you are designing or implementing it into a real base. Now, if we integration with the classical machine learning. I have said this hybrid quantum classical model is important. Classical computers handle pre-processing. Here also quantum processor solves the optimization task. Integration with the deep learning frameworks, I said that it also integrates the deep learning concept into a quantum machine learning. And also it improves the accuracy and efficiency. We observed not only the programming in real application when we implemented as a computer science researcher, I observed that actually it improves the accuracy and efficiency, but sometimes due to some challenges, maybe we observe that accuracy is not good with respect to the classical machine learning implementation. The reason behind this may be some implementation issues, some bit state computation or changing the qubit into a state. So in that reason, sometimes we face challenges to improve the accuracy, but it's obvious that it is always efficient in the time execution path if you take that also. So practical for current NISQ devices, which is very popular. So these mostly challenges. I have highlighted the major challenge, which is limited quantum hardware availability. This is the people, hardware engineers, computer engineers, quantum mechanics expert. They are all concentrating on the limited quantum hardware availability. So people are working very hard, very hard work doing this actual getting into a quantum hardware availability in the world. So everyone facing this challenge. So I feel that new era of computing, it should be solved. But still, we as a researcher are facing the challenge of building the quantum hardware. Now, this quantum noise and uh, decoherence, these are the important challenges. High implementation cost. I have said sometimes I personally face that when you are implementing into your laptop, it sometimes crashes. So I personally face such implementation problem when we are using this UML. Lack of large scale quantum computers. It is true, if we have limited quantum hardware, then it is not possible to get a large scale quantum computer. Still, for getting and executing it, it is required to queue for IBM computers, and you have to pay. So people are not interested to pay. So in India, there are many challenges to improve the large scale quantum computers. So it is definite that in this direction people are working hard, and researchers are also working. So shortage of the skilled professionals. Yes, this is very challenging challenging topic. That in fact, when I was started to know this quantum mechanics, mostly after my thesis, after my PhD in 2024. After that, I want to learn this quantum mechanics, try to learn this quantum mechanics and quantum machine learning. But I able to at least small range implementation in the year of 2000, end of 2025. The reason was I felt a lot of challenges to implement it into a real computer. So that's the reason that there are many people, many students, many researchers don't like this. But I feel that this is a new era of computing. So we have to adopt this technology, we have to learn this, and you should use it because this complexity reduction, speed reduction, complexity, execution time reduction is a vital part which is already shown by the various researchers in the field of quantum machine learning. So the features of quantum machine learning is breakthrough in medical research, which is the topic for hours in the FDP, smart agriculture, climate solutions, development of fault tolerant, quantum computers, faster AI model training. That also I have talked previously. So faster AI model training and faster fault tolerance, quantum computer objective is mostly this speed up the execution. And also advanced cyber security system I have also discussed in some slides for real life application on quantum machine learning. So advanced cyber security systems which is also implemented, which is also the part of the researcher concentration. And also real-time optimization in industries, mostly controlling in a real-time system, and their optimization in embedded system also, this real-time embedded system also, optimization in industries use these techniques to reduce, you optimize the time, and also the potential revolution in artificial intelligence. It is true fact that potential increases if we understand the concept of computer, quantum machine learning, and also other features. So, so I feel that these are the major conclusion related to QML, and I have discussed very overview concept of the quantum machine learning. I have not discussed in details. I said that if I discuss in details mathematical parts and other circuitries, maybe it will took more time. It is a overview only for the quantum machine learning. So in conclusion related to quantum machine learning, I can say that QML combines the power of AI and quantum computing. So this combination, every time, every way, when I'm discussing in my wordings, every time I mention this is a combination of tools, technologies, and mathematics. It offers faster and smarter computational methods. Yes, it is obvious. This quantum machine learning, it offers faster and smarter computational methods, and is still in early development stage. I said in India, mostly we are suffering from the implementation issues by the computer science student, computer science researcher. So it's still in early development stage. We cannot tell that we are in advanced level of quantum machine learning. No, we are in the very basic childhood type stage in implementing the QML. So it is required huge potential for future research and innovation. So I request all the participants at least learn this QML, and it is very vital for the next generation research. So I'm expected to transform these multiple industries in coming years. So mostly every people other than India, other countries also, they are concentrating on the topic QML. So with this, I'm concluding my very basic overview about the topic. So now And in the next on scheduled time, maybe I will discuss mostly on Gen AI and other classical machine learning and how this QML and mostly this QML and AI tools are helping in medical device to make them smarter and computational expenses to reduce. So how that should be done with the help of that conclusion, uh, I would want to like some feedback from the participants, participants, that uh, how was the session and what are the new things maybe I will include in future presentation of mine in scheduled time. And also I will request our associate professor from mechanical department, which he is going to discuss based on the rescheduling of his session. Probably I will announce in the WhatsApp group as well. So now this is time to take feedback from the participants and respected other professors, those who are online. I feel that now we will conclude this session with this. So thank you all participants. If you have any questions, please ask questions and give me a few feedback so that I will include some more slides for the presentation of mine, so that you people will understood the basic concept and implementation of UML in healthcare system. Okay, thank you.
Hello, sir.
Yes, madam.
Sir, I'm Dr. Sabina from Kerala. So thank you for the introductory session on quantum machine learning. Actually, I have joined this session to hear the quantum machine learning part. Anyway, you have shifted it to the first day itself, and I'm expecting your session on 26th also. So my doubt is, actually, if there are the quantum PCA, quantum SVM, so many variants are coming today. So is it possible to implement these things in Python or any special language, or any I mean, is it possible to implement it in a MATLAB and Python? Any functions are
In
there?
Python it is possible. In Python it is possible. Okay. So
Hmm.
whatever I shared with these PPTs link, you go through this link and PPTs. I will share my content also also after the session. So you go through this resource website and what are the concept resources I have shared in the PPT. So you go through at least basic things. It is possible. It is possible, madam.
Okay, and one more question is, if we can implement using Python, then what is the difficulty you are mentioning? It is high, there is quantum machines are required for the implementation, and
Yes,
it is so.
yes, it is true. It is true that actual quantum bit, creating this actual quantum made, I discussed that it is required to implement building new hardware and implementing into it to actual implementation. But this is one kind of simulation we have done, not like that this real bit. Okay, for real bit actually available in India, maybe IBM. Okay, so you have to you have to approach them and you have to pay for that to use this real weight for computing in quantum machines. So that is the major challenge I discussed several times during my session, that we are in a infant state of implementing this QML, because we don't have this mass computational hardware for implementing the concept. Yes, true.
Usually this even PCA, we need not do it in hardware form. But if it is quantum PCA, if you are doing it in the same way as normal PCA in using Python, is it valid? Can we consider it as a quantum ML part? Quantum, that is QPCA or QSVM, like that. If we are doing it in Python, is it valid? Can we publish the papers with that?
Yes, yes. Now it is publishing. I'm myself also published a few papers recently in Zcon. Also, I have published one hybrid QML topic. So IEEE Zcon conference. So I am also in the phase of learning. I said that it is not like that in India. This is very early to learn this quantum machine learning. There are many challenges we face. And myself, when I start to learn, I said in 2024, after my PhD, I started to learn this concept. So it's still, I'm also learning. So probably your question is like very basic things with
Yes, sir.
very basic things which are really, in fact, required to the awareness of the people in India, so that people will get more interest. And that is the idea of this faculty development program. And I am planning to give more details in the next session. So I feel that if you go through at least the basic things
Yes.
and basic resources related to quantum machine learning, so that you will get more things. So
Yes,
yes,
sir.
that is in the infant state at India. So it is together we have to come approach to solve the problem and build this new quantum computer. Yes.
Okay, thank you, sir. Of course, I'll refer the fundamentals and we can have a discussion on the next session. Thank you.
Yes. Very good. Thank you for your good questions. Thank
Okay.
you. And is there any other questions from participants? As it is online, so I'll be still very happy to hear from you some questions. But yes, everyone together we have to learn. I cannot do these all things alone. This is the time to learn quantum machine learning. As I said, that we can reduce the execution time mostly when you are implementing. But there are real challenges. Like I mentioned during the session also, when I started to implement it. Like your question also like that. So we use components like capacitor, transistor to store particle. So how can we store this? Yes, yes, that is the hardware implementation. You are talking about this hardware implementation. So in mostly the quantum mechanics people, researchers, they are working on to find out how the hardware should be implemented to improve the computation part. Okay, so that's how people are still working. Okay, this QML is a new concept we are going through. Okay, so I said also that it is important to know all these combination concept, which you are learning machine learning on other concept is important. And it is obvious that you have to learn how your classical state should be transferred into quantum state. Okay, so if you able to do that, that means you are half done. Okay, so that you take a lesson from this, that how you should go through these things, and you understood this. Okay, so based on this basic information you go through once, then we'll discuss more on the next session probably. So it is time to closing. Is there of those who are offline? I will take their question, but online, yes, online, is there any question to me? So if you don't have any question from the participants.
Sir, one more request, sir. Sir, is it possible to show one case studies you have done using quantum machine learning in your next presentation?
Case study, I will do one real problem which I have solved.
Okay.
So
Okay.
that case study I will discuss.
Okay.
Good.
Okay.
The case study is important. Yes, I will do that case study discussion, and mostly quantum machine learning based on real publications and what is exactly that thing. Maybe I will discuss in the next session. Okay. So most welcome. So if you don't have any questions, so I'm closing this session. It is close to 4, but I was not well prepared. Sorry, because it is unfortunate. I'm making another sorry for the problems, but I feel that I have given my time to adjust these situations, handling these real time problems again, to conducting these FDP. So I feel that everyone be happy, and we resign. We will resign again on tomorrow the morning sessions. No, the afternoon again, the same times at 1 p.m. So we'll be there. So thank you for these sessions and joining us in the FDP. So thank you to all participants. So I feel that you will be happy, and we will also be happy to promote this faculty development program, and you should learn something. Okay, thanks a lot to all. Sandeep sir, Dr. Sandeep, are you there, sir?
Yes, sir. Yes, sir.
So is there any feedback from your side, sir?
Yeah. Already we have entered that form in the chat box. Feedback form that we already entered.
Okay, sir. Means anything from my next session, which should I include? I feel you also observed that anything that I have not discussed today, because I was not well prepared also for this session. Okay, that happens. Good. I feel that everyone enjoyed these sessions. So thank you.
Yes, sir. It was a very wonderful session and very innovative.
Okay, thank you, sir, for your feedback. Okay, so
Yeah.
I'm closing the meeting now. Okay.
Okay, sir. Okay.
Thanks a lot. Thanks a lot.